Work and energy. Work, work done, positive and negative work done. All living beings need food. Living beings have to perform several activities to survive. The energy for these activities comes from food. We need energy for other activities like playing, dancing, reading, writing, thinking, jumping, and cycling. We too get engaged in activities. For example, we run, lift weights, pushing or pulling load, plow fields. All such activities require energy. Think of machines. What do they need for their working? Why do some engines require fuel like petrol and diesel? Why do living beings and machines need energy? What is work? There is a difference in the way we use the term work in day to day life and the way we use it in science. To make this point clear, let us consider a few examples. You are working hard to push a huge rock. Let us say the rock does not move despite all the effort. You get completely exhausted. However, you have not done any work on the rock as there is no displacement of the rock. A boy pulls a trolley bag and the trolley bag moves through a distance. The boy has exerted a force on the trolley bag and it is displaced. Therefore, work is done. Scientific conception of work. A closer look at the above situations reveals that two conditions need to be satisfied for work to be done. A force should act on an object and the object must be displaced. Work is done only when a constant force applied on an object causes the object to move in the same direction as the force applied. Work done by a constant force. Let a constant force F act on an object. Let the object be displaced through a distance S in the direction of the force. Let W be the work done. We define work to be equal to the product of the force and displacement. Work done is equal to force into displacement. W is equal to F into S. The SI unit for work is joule. 1 joule is the amount of work done on an object
when a force of 1 Newton
displaces it by 1 meter along the line of action of the force. Positive work done. The situation in which the force is applied in the direction of displacement, that is, force and displacement are in the same direction. In this situation, the work done will be equal to the product of the force and displacement. In such situations, the work done by the force is taken as positive. Negative work done. The situation in which the force is applied in the opposite direction of the displacement, that is, the angle between the two directions is 180 degrees. In such a situation, the work done by the force F is taken as negative and denoted by the minus sign. The work done by the force is minus F into S. Energy. Life is impossible without energy. The demand for energy is ever increasing. Where do we get energy from? The sun is the biggest natural source of energy to us. Many of our energy sources are derived from the sun. We can also get energy from the nuclei of atoms, the interior of the earth, and the tides. How does an object with energy do work? An object that possesses energy can exert a force on another object. When this happens, energy is transferred from the former to the latter. The second object may move as it receives energy and therefore do some work. Thus, the first object had a capacity to do work. This implies that any object that possesses energy can do work. An object having a capability to do work is said to possess energy. The object which does the work loses energy, and the object on which the work is done gains energy. When a balloon is filled with air, if we press it, we notice a change in its shape. The shape continues to change as long as we press it gently. It can come back to its original shape when the force is withdrawn. From these examples, energy is the capacity of an object to do work or the ability of an object to produce change in itself or the environment. The energy possessed by an object is thus measured in terms of its capacity of doing work. Therefore, unit of energy is same as of work,
that is joule.
1 joule is energy required to do 1 joule of work. Sometimes a larger unit of energy called
Kilojoule.
kJ is used. 1 kilojoule is equal to 1000 joule. This is all about this subtopic.